A plumbing system built from unverified, unmarked pipes carries the constant, invisible risk of a sudden, catastrophic rupture. Welcome to Insight Engine, a high-yield review series developed in collaboration with JCB EduBuild Solutions and engineer James Bolo. Today, we are reviewing Chapter 14 of the revised National Plumbing Code of the Philippines, Quality and Weights of Materials. Many examinees fail this section because they attempt to memorize hundreds of individual dimensions and weights in a vacuum. To solve this, we use the compliance matrix. This three-pillar structure, identification, specific materials, and components, provides a deductive path through the code requirements. Chapter 14 functions as a logical system, where the specific application of a material dictates its required physical properties. We begin with the first column, identification. Material compliance begins at the factory, long before the components ever reach the job site. Section 1401.1 establishes the baseline requirement. All pipes, fittings, and fixtures in a plumbing system must be free from defects. According to Section 1401.2, every component requires an integral factory-applied stamp or logo that identifies its weight and quality. This is a critical point for the exam. Field markings are strictly invalid. If the identification wasn't applied at the factory, the material is a high-risk liability. Section 1402 introduces the iron pipe size, or IPS, standard. All iron, steel, brass, and copper pipes must conform to these universal dimensional and weight baselines. We can now lock our first column. Identification requires a factory stamp and IPS weight conformity. Without these factory-verified markings, a material cannot prove its origin or its ability to meet the code's safety thresholds. Next, we move to column 2, specific materials. In Section 1403, we see that for copper tubing, the color of the factory stripe determines its legal use. Section 1403.4 mandates a continuous, indelibly colored stripe for hard-drawn copper, green for type K, blue for type L, red for type M, and yellow for type DWV. For drainage and vent piping, Section 1403.1 permits type DWV copper, which is identified by the yellow stripe. Potable water supply requires a heavier wall thickness to withstand pressure. Section 1403.3 sets type L, the blue stripe, as the minimum requirement. Type M copper, marked in red, is restricted. It can only be used for water piping above ground or underground if it is provided with an approved protective coating. Section 1403.2 specifically prohibits the use of copper for any piping carrying chemical or industrial wastes. We update our matrix with these coding rules: blue for water supply, yellow for standard drains, and red for specialized coated applications. For copper installations, the colored stripe is the governing indicator of legal use. Using a red type M where a blue type L is required creates a significant compliance failure. We continue in column 2 with lead. Section 1404 establishes standards built around minimum density to ensure corrosion resistance. Lead-safe pans must meet a high-density threshold of 19.56 kilograms per square meter and a thickness of 1.6 millimeters. Flashings and vent terminals, which face less mechanical stress, have a lower threshold, 14.63 kilograms per square meter at 1.2 millimeters thick. Let bends and traps require the most protection, with the code mandating a minimum wall thickness of 3.2 millimeters. We add these mass thresholds to the matrix: 19.56 kilograms for pans, 14.63 for flashings, and 3.2 millimeters for the walls of bends and traps. Because lead is inherently soft, the code uses these density requirements to prevent structural failure at critical nodes in the system. We move to the final column, components. These are the interfacing nodes where fixtures and controls meet the piping network. A compliant closet ring must meet specific dimensions, a diameter of approximately 178 millimeters with a 38 millimeter wide flange. These rings must also feature a groove face designed to receive the fixture gasket or ball wax, ensuring a gas-tight and watertight seal. We also look at valve bodies in Section 1410. Here, the diameter of the piping determines the required material. Section 1410.1 specifies that gate valves used in drainage work that are 102 millimeters or larger must have cast iron bodies. For sizes smaller than 102 millimeters, the valve bodies must be cast brass or bronze. Finally, Section 1410.2 requires that valves up to and including 51 millimeters must be made entirely of brass or bronze metal. We finalize the matrix: 178 millimeter closet rings, cast iron for large valves, and brass for small diameter controls. The volume of flow dictates the necessary strength of the valve body. Larger systems require the rigidity of cast iron to maintain structural integrity. This completed compliance matrix provides a logical framework that mirrors the data structure of the official Plumbing Material Standards Table. Table 14-4 is an exhaustive list of ANSI, ASTM, and ISO specifications. It is difficult to memorize, but easy to navigate if you know the underlying rules. Use this matrix as a deductive tool during your exam. It tells you exactly which weight, color code, or material body to look for in the tables. This is a module of Insight Engine, presented by JCB EduBuild Solutions and engineer James Below. Understand the fundamental technical specifications of these plumbing materials, and the right answers on your exam will naturally follow.